Right, so we are now live. So welcome everyone. We are absolutely winging this. Well, I'm winging this. So welcome everyone to the Festive Tech Calendar. This is Monday the 4th. I had to look at the calendar there. Today I've got David O'Brien all the way from Australia, and he's going to be talking about how he built a highly scalable SaaS on Azure. So it's an Ask Me Anything. So I don't know if we've got people. Let me just check. Let's go into comments. Right, I'm not sure. Unfortunately, we're playing three AMAs at the same time, David. So I'm not sure if people go along, but I've got. Let me just close my calendar. I've got plenty of questions that I can ask. So let's do this. Right. So David, introduce yourself a little bit first, and then we'll go from there.
Sure. Well, you already said David O'Brien. I'm based in Geelong, Australia. So our Christmas is very hot at the moment. It's 9 p.m. It's still 29 degrees.
It's about 0 here.
Yeah. We're very envious of all the snow Europe got yesterday and the day before. At least I am. Most people here go, "Oh, it's finally summer." It's good here. What do I do? I've been doing cloud for 15 years now. Like when Microsoft had their private previews of Windows Azure, can't even remember what it was called back then. Amazon only had 3 services. We're now over 300 on each of the cloud providers. I kind of specialized or focused a lot on security, on cloud security. I'm not a hacker, I'm not a pen tester, and none of that. I attempt to help organizations do the cloud well and securely. And 3-ish years ago, I founded a company called Argos Cloud Security, which is a cloud security product focusing on helping consultants do cloud assessments easily, quickly, and accurately. And we built that on Azure, and I'm happy to answer any questions that people might have.
So if anyone does have any questions, please do ask away. If you're watching this on repeat, like watching it back after it's live, please do ask questions in the comments, and we'll get back to. We'll send them on to David and ask. I've spoke to you. Yeah, I spoke to you about this before, but I've still got probably loads more questions.
That's all right.
So you've been working on this for 3 years.
3 years, yeah. Startup is funny. You think you know what you're going to do, and then it hits reality, the real world, and you go, right, okay, like that was a good idea, but people want something different or a slightly different flavor of what you wanted or what you were thinking about building. So Argos went through a couple of iterations to get to where it's now. I guess the way we started building it actually helped us make sure that we were able to easily iterate and not have to focus too much on the infrastructure.
So that's an interesting thing. So you and what would you say was the good idea about what made that so flexible?
Yeah, we from day one, I was a very big virtual machine OS person before, like 2015, 2016. I used to be a config manager MVP, SCCM MVP, PowerShell MVP. So a lot of operating system stuff in the past, and I think when we sat down and designed Argos, the very first thing I said was no VMs. Like there was that was one of the golden rules almost. Like no VMs. Make sure that we can focus on the app, on the outcome, and not have to worry about all these side quests, if people remember those from gaming. Focus on the main thing, the application, and what we actually want to achieve, rather than great, now we need to deploy this patch to this VM or whatever. So from day one, said serverless, whatever that might be. We ended up doing Azure Functions at the time, and we still are very, very heavy on Azure Functions. No, nothing where we had to worry about the operating system. It turns out we still do sometimes worry about the operating system, even on Azure Functions. But I think saying, look, we go past very, very high, or make sure we push anything we can back to a vendor, or essentially outsource that worry or that concern to, in this case, Microsoft, just made sure or enabled us to go, all right, we're just going to test something else without having to worry about deploying new VMs or something like that. Made it very easy for us to do that.
It's interesting because when I joined Intercept, I was basically asked in my interview, what do you think of VMs? And I was like, oh, don't like them. And they're like, good, because neither do we. So it's the same sort of concept that Intercept have. No VMs if we can get away with it. So we try and get everyone off VMs as quickly as possible. Now, that's obviously not always possible when you're migrating stuff, but we don't ever have a design where we recommend VMs for anything.
No, and like I said, I've done plenty of cloud, and especially in large environments and more legacy environments, VMs are an unfortunate reality, especially when you go and you buy COTS, like commercial software. A lot of the vendors go, oh, you must deploy a VM because we don't know cloud. So we know it runs on VMware, so it's going to run on a VM in the cloud. So plenty of larger organizations and small organizations as well need VMs. But we were in that position where we went, all right, we're greenfield. We can decide what we want, and so far we managed to stay away from VMs. There's no need for us to deploy a VM. Like I said, we do sometimes have to worry about the operating system, but that's more if there's a dependency in our app, a third-party package, where we go, okay, that requires, I don't know, some Windows or it must run on Linux.
We've got a question from, I'm probably going to butcher this person's name, Chaitanya Kumar. He says, no VMs. Is it not difficult for teams to adopt if they do not have serverless expertise? Great question.
That's a good question. And in our case, no. The interesting thing is, so our team is full on all developers, basically. I wouldn't call myself a good programmer, especially if you ask my team. There's happened more than once where I go, oh, great, I can do this feature. Quickly go and code the feature, and it kind of works until it doesn't. And then I go, hey, such and such, here's my pull request, here's my branch. Can you go fix it? The team is very much focused on the code. And I think, especially as a startup, that means they don't have to worry about anything else. They just need to worry about writing the code. And it actually makes it much, much easier to just focus again on the outcomes. Nobody should have to worry about patching an operating system unless you're working for a large cloud provider, where it's your day-to-day job. You have to worry about the underlying operating systems. But unless you're really forced to by third-party dependencies, I don't believe people should have to worry about virtual machines.
Okay, so there's a follow-on question. So what are the easiest ways to adopt to serverless for teams who are used to predictable cost of VMs?
There's an implied statement in there. Predictable cost model of VMs means you're not actually scaling in the cloud. You deploying a standalone one single VM, which in my opinion is a cloud anti-pattern. You're using the cloud as a hoster at that point. And you deploy the VM, you have it running however long, most of the times 24/7, unfortunately. So that's that predictability. We can predict our cost quite well, actually. We serverless is a bit of a misnomer, anyways, especially on Azure, unfortunately. Because if you want to have certain security, I don't even like calling it security feature. But if you need VNet integration, for example, on Azure Functions, you have to deploy an app service plan, which means, or you have to get onto a premium plan, which means you're kind of not doing pay as you go, pay by use, anyways, because you're deploying not dedicated, but shared dedicated compute to you. Which means you can actually go and predict the cost quite well for that, because it's static cost and you scale on that. And you kind of have to sometimes go by the cost in the cloud is like a spectrum. Like it goes from low usage to high usage at peak, and you probably have to learn the way or the usage patterns of your application over time. So the first month or the first week or whatever might be a bit of a learning time for your application to understand how it's being used. If you've scaled it correctly. For example, our backend is Cosmos DB, which is notorious for being very, very expensive if you scale it incorrectly. And so that took us a while, and to get that right, for example. It took us actually quite a few meetings or sessions with Microsoft and their support to scale the RUs on our Cosmos backend properly. But yeah, I think the easiest ways to adopt. Sorry, that was the question. The easiest ways to adopt serverless for teams is really to get them to think about the business case, and have them not think, right, how do we deploy this VM? How do we deploy or make sure that VM comes back up when it dies or something like that? You push that up to serverless. You really only talk about how does one service talk to another, interdependencies of these. I don't want to call it microservice. We're not doing really microservice at Argos anyways. We deploy a big monolith with lots and lots of tiny functions in it. But I think it's really a mindset change that people need to go through. Really, the way people develop the applications, probably, like from a developer point of view, probably doesn't change too much on functions or any serverless. They should have always, which is kind of what sysadmins and the likes always complain about, and complain about, is the whole, developers don't care about the VM, they don't appreciate the complexities of it. Yeah, neither should they, right?
Like you're spending more time concentrating on building the features out of the product and not worrying about as the VM started, is it backed up? Yeah. So that's the goal of what you want to do as a SaaS. Do you know what I mean? You want to concentrate on the product rather than concentrating on what's powering the product. Yeah, that makes a lot of sense. Yeah.
Exactly. Like we have like our product is fairly low touch from our point of view. Like new customers onboarding to our product is really, really low touch. Individual people completely self-serve via the website. They don't even have to talk to us. So every once in a while we go and look at the metrics and we go, another person signed up, and they started scanning this massive environment with over 100 Azure subscriptions in one go.
And, sounds like what I might know.
And it just worked, right? When Argos is not needed, it does run in the back end and does continuous scanning. But if it's not needed to to scale out a lot, then it doesn't. It scales back in automatically. And we don't have to do any really of that, except for in our infra code, we make sure that the app service is configured correctly, and then Microsoft takes care of the rest. And that's really the beauty of that.
That comes back to the guy Chaitany's question. The predictable cost of model of VMs means you're not scaling, because if you were scaling, it wouldn't be predictable. Because that's one thing when we're doing designs for customers. They're like, we want auto scaling, and I'm like, okay, but we can't give you we can't tell you what your monthly bill is going to be, because we don't know what it's going to scale up to and scale back down. So that's when it becomes a little bit tricky. You have to kind of guess roughly this will be your bill, but if you scaled it out to 10 instances, then it will obviously go up, and if you scale it back down to 3, it'll go back down. So
and I guess that's where you then have to average that out over time, right? You need to understand the usage pattern of your users, and go, okay, so every Monday morning people go, depending on what type of application we're talking about, right? Every morning people go and log on, and it spikes out, scales out. Half an hour later it scales back in because people, I don't know, timesheets or something like that, right? It's not always used, but then when it's used, it does need a lot of compute. You learn that behavior over time, basically, and go, right, this is the maximum, this is the minimum, this is how much it's going to cost us. And there's plenty of
that's a very good. Yeah, I get that. Yeah.
But you can, right? That's the thing. But you need to learn. You need to understand the behavior of your users. It's not you're going to go and deploy a VM and have that running 24/7. You shouldn't be doing that anyways, even with VMs. That's not a good idea. And in VMs with scale sets, for example, new scale sets can now use spot instances as well, where you go and you bid on compute. That would be an amazing use case to scale out on VMs with scale sets. Functions is the same. Like you can predict it to a point, right? You can. It's just not that you can go and say, okay, this one thing costs this much per minute, and I'm going to use it 232 minutes.
Next month. That's we have a tricky time trying to explain that to people. You know, that I keep telling people, you're using the cloud for this capability of scaling and elasticity and all this good stuff, and that's why you're using the cloud. So you have to try and, I almost tell customers you need to wait like maybe 2 to 3 months to see what your bill's going to kind of settle down at. Because at the start, it might be too powerful, or there might be, you might have scaled it too much at the start, or the opposite, where you haven't scaled it enough and it goes up. I get the fact that Chaitanya is saying that he can't tell his CFO that we can't predict costs, but you can to a degree, as you said. You just can't be, this is going to cost $2.99 a month. You can't do that, but that's part of the cloud, really.
Yeah.
But you're getting a benefit and a lot of new features that are amazing. So you're kind of, it's kind of balancing act.
Yeah. And I think what people sometimes need to also keep in mind is you shouldn't really care too much about people tend to focus a lot on the per minute runtime cost of something. But what people really should worry or focus on is the total cost of a service per month. And one thing, for example, that people in my past, when I spoke to customers as a consultant, that what came up all the time was, but a VM, I can have a VM for $100 a month and have my application running on that VM for $100 a month. I said, yeah, you can, but it's not going to cost you $100. It's going to cost you $100 plus your time. Your time figuring out how to make sure that that one VM is going to come back up once it dies. That automation, that work, patching, backing up, the backup cost. The total cost is much more important And that's what the CFO cares about. The CFO doesn't care about that service costs, I don't know, 80 cents a minute, and the other one 70 cents. It's the total cost, the budget the team requires, right? And that's what drove us to serverless or to Azure Functions and all the other PaaS services on Azure, because it was a lot cheaper. We didn't have to hire a sysadmin on day one. We still don't have a sysadmin. I look after the infrastructure, but we were able to focus on what our customers needed and not what our VMs needed. It's much more important to focus on what the customers need rather than what a VM requires.
Yeah, I mean, have you ever run into scaling issues using functions even back in the day, or is it always no?
Not with functions. No. We had some very weird issues with functions, where and that's the interesting thing about PaaS. When you deploy a function app and you say version approximate 4, like the tilde sign, that really means any version 4. And Microsoft goes and then updates the function runtime, right? And sometimes even minor updates can just totally screw with the application. We had that, I think, twice, where we went, so we didn't make any code change, and it doesn't work anymore. And then Microsoft went, I think we just deployed a new version to that availability zone, that data center, and go, maybe just pin the version, but you can't pin. I don't think you can pin minor. You can pin major. I'm not sure if you can pin the minor version on function. So that was interesting. Once we actually had to delete the function app and redeploy, and then they made sure that it ended up on a different rack or something. But sometimes even serverless, you do worry about the underlying system.
Yeah, no, I've had some issues with functions. It's mainly in the portal when you get something like, was it function runtime not detected or something like that?
Oh yeah, not available.
It doesn't seem to do anything, and you're like, well, what is going on here? And it's stuff like that can be quite tricky to debug. I've seen I had a customer who was using Azure DevOps pipelines to deploy functions, and one day it was just like function runtime unreachable, and I was like, it becomes tricky with that stuff. But I'd much rather do I'd much rather do serverless than VMs for all of the above that we've mentioned.
Absolutely.
So let's just chat a little bit about why not microservices. I understand why, but what's your reasoning for not wanting to go down that road?
We're a team of 5, right?
Yeah, thinking out loud here, you could potentially rewrite it from functions to .NET and then host it in AKS and then put it or even on Kubernetes and run it anywhere.
Yeah. So our application is written in .NET Core. It runs on Linux. .NET Core runs on Linux. And we don't have any dependencies anymore that require Windows. So we're on all app services are Linux now. The reason for no microservices was really our team is way too small for that. We don't need that. We don't need these independent building blocks. It's one binary that gets deployed at the moment. It's 3 binaries now. We did split into 3 logical functions. Our scanning, our app, like the front end APIs, our scanning, and our reporting APIs. Actually, technically a 4th now, our AI API. But it's the and then why not AKS or Kubernetes? Because I don't think anybody really wants to work with Kubernetes. So AKS was out very early on. Container apps is a different story now, where the whole Kubernetes ecosystem is just hidden away, right?
Mhm.
You don't have to worry about node pools and VMs anymore. So that's all hidden. So we are moving a couple of things to container apps. But that said, we're still not using any really Kubernetes ecosystem stuff.
I get that.
There's no service mesh. We do have a lot of everyone wants to work with Kubernetes, really.
I'm not going to say it.
I'd like to know why. So we're a very small team. None of us are Kubernetes experts. There's nothing in our application that would require to go containerized, to go Kubernetes. We actually use a lot of function bindings and triggers that are not API. We use a lot of durable functions in our core application. So if we even were to move to AKS, we would have to run function runtime on Kubernetes. So yeah, that in my opinion should mean that you should just you should tell people even more so they shouldn't run Kubernetes, but leverage the whole ecosystem, but the whole ecosystem around Kubernetes. Yeah, my point is that there's an amazing ecosystem around Kubernetes, but Kubernetes itself should really be taken care of by Kubernetes experts, and I don't think there's that many overall. Certainly, I'm not one of them, and really all of those people should work for cloud providers and very, very large enterprises that might really, really need some almost specialized Kubernetes implementation just for whatever they need to do. But the random generic organization, I don't think they would do themselves a good service by using Kubernetes. Especially us as a startup. Why would we run anything on Kubernetes? Container apps wasn't around when we started. That might have changed this now a little bit, because container apps, in my opinion, is quite a neat service. It's still very young and fresh, and young and fresh could be replaced with some other adjectives in this case as well. It's not very mature at this point. So function apps is a well-used, well-trodden path. It really just works and gives us a lot of things that we just, again, didn't have to worry about. Like us needing to send emails, we just use a SendGrid binding. So we use SendGrid to send emails to our customers, and we didn't have to write any code for that, really. Function apps have a binding, a native binding for SendGrid, and it just meant, again, we could focus on making sure we write great features and make sure the application works well, rather than having to worry about how to write the code to talk to SendGrid.
Okay, let's for people who don't know anything about Argo, or is it Argo or Argos? How do you pronounce it?
No, we're Argos. Argo. We're not Argo CD. So
Yeah,
Argos. Yeah.
Argos. Right. So for people who don't know what that does, if I sign up and I run a scan, tell people what's that doing in the background.
So you sign up, you put your Azure Access token in for that has access to an Azure subscription, and that then essentially triggers a durable function, an orchestration that goes out to your Azure subscription or the Azure subscription that you selected using that access token, and essentially uses the .NET SDK to call all the Azure resource providers, the APIs, and it creates an inventory in our Cosmos DB backend of the whole environment, builds up a graph of the environment, and we then assess that graph for security issues. And there's no requirements on your Azure environment, nothing you need to have enabled or configured or anything. You just give us that access token, and then Argos figures out the rest. And it's really there's quite a lot of functions involved. We have over, I think in total, we're now talking over 180, 190 individual functions that we have that do lots of things, hand waving, lots of things, and yeah, like I said, lots of durable functions. We initially had a lot of storage queues where one function put a message onto a queue that triggered another one. When durable functions got released and really with scale at some point, we needed to pass that over to, like, initially we had the orchestration built in-house basically. We passed that over to durable functions, and ever since it's actually working really, really well.
So do you have like the main orchestrator function called the first function, and what's it doing in the background? Is it building up like a JSON document and then you're storing that in Cosmos? Is that how it
Yeah, pretty much. So for each of your cloud resources, we create a JSON representation on our side. So that means the larger your environment or the environment of your customer is, the more JSON documents we create. That was quite interesting at some point very early on. To your scaling question before, it wasn't really a scaling problem on our side that we couldn't scale fast enough. It was mostly Cosmos DB throttling us. So we had to figure out how to make sure that we don't get throttled. And that's when we then had to work with Microsoft to figure out the correct RUs. We realized, for example, that certain queries we created using the .NET SDK weren't actually that good. So we created the queries ourselves to write to Cosmos instead of using Link in .NET. Because Cosmos, it's actually quite interesting, depending on where you put certain filters or certain keywords.
Makes a big difference.
Yeah, a very big difference.
In cost, yeah.
Exactly, especially in cost, because you pay by the RUs basically that you deploy, that you get provisioned, and unlike a SQL Server where you go, that spiked the CPU a bit, or something like that. Every not so great query you create on Cosmos can cost you a lot of money, and so we had to figure that out very, very early on. And but yeah, we have basically a main orchestrator function or workflow that then triggers other orchestrations that then trigger other functions, and eventually, like, imagine it. No idea where we start, left or right, or how it's mirrored, but we kick things off, and then it fans out into lots of small functions, and then it comes back in, gets processed, gets written out to Cosmos, and then reported back to the customer. So there's some really nice, intelligent scaling and fanning out that works.
Yeah, sounds awesome use for durable functions, to be honest. Yeah. And how did you find debugging them? Because when I first did, I've only done one project with durable functions, and it was like a bit of a learning curve to begin with. We were like how to figure out what was going on, and then do you find that was that quite difficult to begin with when you started doing durable functions? Or
yeah, initially it was a bit weird. Okay, how do we know what's actually running at the moment? So we spent quite a bit of time initially getting our logging well. So it really made us put quite a bit of thought into logging and making sure. So we use Serilog on our side to create some nice logs. We pump them out into application log analytics and then application insights. A lot of the debugging happens locally on our side, so we can run Argos locally very, very easily. Again, because of Azure functions, so you go into Visual Studio, hit F5, and it works.
Another good reason.
Yeah, and it works really, really well. And that was also one reason probably why we also didn't go full containerized. It makes things a little bit more complicated sometimes when debugging. I'm not saying it doesn't work. It's just that there's also a lot of setup at that point required for new team members to join. All of that can be a bit more streamlined nowadays with GitHub code spaces and all of that kind of stuff, right? Microsoft with their Dev Lab, what did they just announce? Dev environment or something. Yeah. So these things make it a bit easier nowadays, but really the debugging of functions is really, really trivial. People just like you hire a developer, you tell them it's a web app, yeah, and they go, oh yeah, cool, I know how to run a web app in Visual Studio. Right?
Yeah.
And there were quite a few very early decisions we made. Like sure, there's probably things where people go, oh, you should have picked whatever language, right? Whatever different language. And I go, yeah, but maybe I can see some arguments. But it's also super easy to hire .NET developers. Like it's almost as easy to find a good .NET developer as a good Java developer because they're everywhere. And I'm not saying we should have picked Java, but .NET, for example, was a really, really good choice. Again, it's super easy to find people. And it just makes things a bit more complicated the more so it's going to come across weird, exotic you get. I'm not saying Kubernetes is exotic.
Yeah, no, I agree.
But people then go, right, I can't run. At some point, we had to use Windows containers, for example, or Windows in our application. So we had to run on Windows. And then some people might go, oh, but I can't run Windows containers on my operating system because I use a Mac. And I don't have dual boot, or I don't. And all of these things, it just makes it really easy. The easier you go, and don't try to be fancy. Your customers don't care.
Yeah,
not once has any customer ever asked us what language is the application written in. Like that was never a deciding factor.
Yeah. What about security? How do you build in security into durable functions and your solution? How does that work?
Yeah, essentially like any other design or cloud architecture, everything is VNet integrated. Everything sits within our private VNet, at least the things that can, and or where it makes sense. Things are behind an API management gateway. Things are behind a NAT. All of these things, we try to do the network security bit. That's one. On top of that, we have Auth0 as our so Okta Auth0 as our identity provider. All our functions use Auth0 tokens to authenticate and authorize, and so we make sure that works. We use API management for users hitting the APIs. So there's a lot of just that well architected, basically.
Yeah. What's your thoughts on Azure API management?
We are not at a complexity where it's gonna be a pain. Let's put it that way.
Okay.
So we have the developer portal public, for example. So people don't have to register and sign up for it, right? That means our API definitions are public, which is fine. The APIs that are being onboarded, they're all protected by a token that we create. There's certain policies we have on there, and to make sure that you can't get around, and you can't just go and inject whatever you want. So that, but I know at some point we probably want to look at something else. We haven't really talked about that. It hasn't really become an issue yet, but I know eventually it will probably be a bit more of an issue. But who knows? By then we might have everything containerized, and we're on Kubernetes, on container apps, and we're talking Istio, and we're behind Kong. I don't know. Whatever it might be at that point.
Have you ever had to do what happens if you have to do a major rewrite? Like what have you thought about that? Like if you ever do want to start doing containers and then doing Kubernetes, how does that look? Do you just keep it running as is while you're feature branching off and doing the rewrite?
Yeah, pretty much that. Yeah, I think that's what it would look like at that point, right? The good thing is that we can actually, and we have just done that. Like I said, we have moved a few things to container apps now that used to run on functions natively, and we pretty much just deployed it side by side. We worked off a feature branch, changed the infrastructure. The application code itself didn't have to change that much, unfortunately. But yeah, we worked on a feature branch, deployed the code, deployed the infrastructure, deployed the code on top of it, and flipped it over. Our functions, like I said before, we kind of split it up into the three logical areas we have: the front-end app APIs, that the static app on storage, our Angular app talks to. The APIs, they're on one function app. Our scanning function app runs on another function app, and then our reporting is also split up into its own binary, and that's now running on container apps. And and the function apps, they use configuration to know where to go to talk to the other parts of the application. So it was really easy to just stand up a new container app reporting function or reporting app, basically. And then once we went, all right, we tested it, it works, it's validated. We essentially told the two other apps, look, you're not talking to that one anymore, you're now talking to that one, and it just seamlessly worked.
Yeah, sounds good. So you mentioned earlier that you're making SDK calls from C#. Why are you not using Graph or anything like that, or REST calls? Is it the SDK is better, or what? Tell us about what the sort of process of that is.
Yeah, the new SDK is actually pretty good now. It was a bit of a weird one when kind of the old SDKs or the old .NET SDKs, and the new packages existed side by side. They still exist side by side, but there's now a bit more documentation for the new SDK packages, the Azure Resource Manager packages as well. That was a bit odd initially, early on, because the way you query Azure looks a bit different now. I must say we didn't have too many issues with it. They're easy to discover, I think. The APIs are sometimes a bit odd to talk to.
Yeah, no experience of that.
Yeah, the SDKs are very helpful now. I think they made it easy, especially for me as well. Like I said, I'm not necessarily a pro or a trained programmer. I'm very self-taught.
Yeah.
I can write code, but don't ask me about theory behind it. The GPT helps nowadays, and Copilot, but the GitHub Copilot in this case. But it, yeah, they just make it really easy to query whatever we want to query.
Is it easy for you to move from one version to another? Is it quite easy to just move that over?
No, it pretty much was a complete rewrite.
Right, okay.
So from the old SDKs to the new one was a complete rewrite of all the code we had. So that was a bit unfortunate. That was a very, very big pull request as well.
Okay.
But
and what about .NET 8? Are you on .NET 8 as of now, or are you still thinking?
No, we're on 6.
6.
Yeah. Which is fine. I think that's still okay for a while. But again, it's fairly easy for us to upgrade. We can test everything before we deploy. Our deployments only take 5 minutes. So deploying the whole app really only takes a few minutes. And if anything did go wrong with something, we can very easily and quickly roll back.
Yeah. Tell me about the AI stuff you're working on.
Yeah. So AI, I'm a big believer and critic of it. I'm always skeptic when people go, yeah, we use AI and AI this, AI that. One of our company values is to be helpful, right? And I think a lot of people talk about AI, and a lot of AI is just not helpful, right? In a lot of cases, it's just a gimmick. And what a lot of people forget is that it's not a magic wand, AI, right? It's and that's definitely something we're seeing as well. So our AI feature basically goes and looks at the graph that we create of the environment, looks at all the security issues that we find in the infrastructure, and instead of you looking at the visual representation of it, the diagram that we create, it's supposed to interpret the issues for you, lateral movement paths, attack paths, all of these issues, and come up with recommendations on how to fix it. And it's very hit and miss. Yeah. Okay. So we use and I'm very open about that. I'd love to get people's feedback, by the way. Our AI feature is it's available in the app, doesn't cost any extra, but it is very early. And I'm very, very transparent about that fact. It uses Azure OpenAI in the backend. It doesn't. We don't train the model. We don't fine tune it with any data. So that's very important. As a European at heart as well, we're very clear on. We send it to Azure OpenAI, our implementation of it, which doesn't use your data to train the models, unlike if we were to go straight to OpenAI, right? So, but we use GPT-4 Turbo. so we just changed the model a couple of days ago to save a bit of money on the queries or on the prompts. But it's GPT is a general LLM. It's not it does an okay job, but it's not a especially trained cloud security model. Google has one. So GCP, after the acquisition of Mandiant, and in collaboration with Mandiant, they developed SecPalm2. GCP uses SecPalm2 in all of their security products or GCP security products, and that actually does a pretty good job at finding security issues. I'm not aware of Microsoft using any specialized security models under the hood for any of their like their security copilot, for example. I think, and I could be very, very wrong here, I think they're also using GPT-4, likely trained with some other data and more data and fine-tuned, probably, which is also why we're currently not using it, because I haven't had time to look at any terms and conditions and privacy policies of it. I recommend anybody who's thinking about using it to very, very, with a magnifying glass, look at the terms and see if any of your data, our data, gets used for the training of those models. Wouldn't be surprised if that was the case. Apparently, Amazon does it with Q to use the prompts and the results for training. But it's very hit and miss still at the moment. So that's why we're really looking for feedback. The interesting thing about this is really the and here's the buzzword, prompt engineering side of it, right? Where the data you pass in and the words you use in the prompt, small changes can make a very big difference. And you sometimes go, but I told you not to do that. Why are you doing it? Because in the following sentence you go and you said something else, and which kind of implied that it might be okay to do whatever you said you didn't want to do, or something like that. It's a very, very trial and error, and but I'm quite excited about it, to be honest, because I do want to get to a point where people, because our diagrams, like any cloud environment, can be quite complex and complicated. And I'd really like to get us to a point where we don't just tell you these are the issues and give you some generic recommendations on how to fix it, but actually get to a point where, this is how you fix it. Because I know other things about the environment that you might not be directly aware of. Like I always go and say, the environment might have an Azure bastion somewhere, and we found a virtual machine with a public IP exposing RDP. And every architect listening to this, watching this, or any hardcore cloud person is probably going to scream and say, nobody ever puts a public IP on a VM. It's the number one of our detections across all of our customers. And if all you have to do is go to showdown.io and search for Azure VMs, AWS VMs, EC2 instances with a public IP on the internet, and you're going to find hundreds of thousands of those. So, but we don't want to just go and say, or have Argos just go and say, take away the public IP, because then you tell that your customer, and your customer goes, but I need to RDP into this for whatever reason. I need to. I want Argos to be able to say, actually, we also found an Azure bastion in your environment that somebody has deployed. Just pick that. Right?
Yeah, very cool. So when you do a scan of like my environment, how do you generate the image? What's going on there? What are you using to generate the diagram?
So we use D3.js on the front end. We create the graph on the back end, so in C#. The magic on the front end is done by a very, very clever person on our team. I don't presume to know how it actually works.
It just does.
It works. It's some very complicated code. So if you look at D3.js, it's a super flexible JavaScript framework to do diagramming. But yeah, with all of that flexibility also comes the complexity. And yeah, I hope, I always hope when somebody goes, oh, that's weird on the diagram, like a customer giving us a message, sending us a message, or something weird on the diagram, I always hope that it's not a bug, because troubleshooting that must be a nightmare. And I'm happy I don't have to do it.
What's been the biggest challenge of starting doing your startups? What's been the biggest challenge so far?
Understanding that the idea you have is not necessarily the end result that people actually want.
Yeah.
So very, very early on, especially as a technical person, that's the idea, and especially as a consultant. You go, but that's what we need to do. And then you talk to people and you get the feedback on the idea, and they go, actually, I think you should be doing this and that. And very early on, like, you really need to fight that urge to go, you don't know what you're talking about.
Yeah.
But that person might be a customer, and you need to listen to your customer. So that was one thing. And the other one was really strict budgeting, to the question early on, right? As a startup, especially early on when you're still building the product pre-MVP, you need to make sure that you're not burning the money you have. You have very limited resources, and need to somehow make do with that. And I think those were really the biggest challenges. The ups and downs of startup life, they kind of go, it's a bit of a roller coaster. Like, you can have the most amazing morning, because like for me, I always get all the European emails overnight when I sleep. Most of our customers are in Europe. So it's currently, like, to the UK, it's 11 hours time difference. And so I wake up and get amazing email news, like new customer signed up or signed the contract or whatever. And you go, oh, bloody amazing. And you finish the day with a customer churning or something like that, right? And you go, why did that now happen? And yeah, it can be a bit of a roller coaster. So as a startup founder, if anybody thinks about starting a startup, really learning how to average out, like, to not get super hyped about things and not super low about things, but go and just take things as they go and hope that track upwards.
So FYI, for people who don't know, our company started testing using Argos, and one of the best things I've seen so far, I've not been involved in it, but the fact that Rennie from our company wants something different, that has a new requirement, and you've turned it around in like a day, that's quite impressive. I'm not going to lie, that's what he's after. So that's a very strong selling point of your thing, that you can basically do that and turn it around within 24 hours, which is fabulous. How do you avoid customers asking for everything? Obviously, you don't build everyone. Everyone does that product mistake where they chuck every single customer request in. How do you decide what's a good thing to do and what's not?
You need to listen for certain keywords. It would be cool if, that's not that goes into the backlog, and we're going to eventually get to it, right?
Yeah.
Creative is not something that people are going to pay for, especially as a startup, right? Especially as a startup, you need to go and find the things that stops people from buying, right? Because that's what it's all about. You need customers or people using it, right? It would be cool if it's not something that people need today. But to listen to the things where people go, look, unless you have that, we can't use it. Or unless you have, and that then, those are the things you need to very quickly go and validate and then implement. And the thing that you asked for was something that other people had already asked for. We have an internal thing. If it's key customers, like our very early design partners and really development partners that we work with, we turn things around very, very quickly. If other people go and ask for a new feature, we usually put that to our existing customer base. We send out newsletters all the time going, hey, we have this feature request that somebody asked for, almost like user voice or Microsoft user voice, and go, what do other people think about it, right? We do very, very clearly listen to what our customers and users want. And if other people go, oh yeah, actually, that's a bloody amazing idea, we go and build it.
Brilliant. Listen, thank you very much for talking about this, because I love the fact that you come on and you'll answer any questions, because a lot of people are like, oh, I'm not going to go into that and stuff, but not your good self. So second time I've interviewed you about this, and I find it super fascinating. I find it fascinating because I love the fact that you are using functions and durable functions, and you're just building this. It's probably super easy to run, super easy to debug, and just cheap to run. Do you know what I mean? So yeah, brilliant.
I'm usually surprised when we tell them how much it costs.
Not a lot, which is good. Yeah. David, thank you very much for your time. Thanks for coming on the Festive Tech Calendar and doing this.
Thanks,
if anyone does have any questions or are rewatching this back and want to ask questions, then I'll take a note of them and we'll get back to you on these ones. But thanks for taking part and spending an hour with me, letting me ask you all sorts of questions. It's been brilliant. Hope you have a great day, and thanks everyone for watching, and we'll see you soon. I'll just click end stream and I'll chat to you in a minute, David. Thanks. Bye, everyone.